Hot water systems, part 2. Going to look now at indirect hot water systems. Indirect hot water systems are hot water systems that heat the water indirectly. That means that the heat source, in this case we've got shown here a boiler. The boiler is the heat source. It heats up the water circulates through the primary pipework into a secondary heat exchanger, normally a coil, and then that water flows back to the heat source. As the water flows through the coil, this hot water flows through the coil heats up, and the coil heats the water in the cylinder. So therefore, the water in the cylinder is heated indirectly by the heat source. There's a few different types of heat exchangers. The coil type, which is shown on the right hand side here, most commonly fitted type. An annulus type, it's not really fitted anymore. In the middle here, this essentially is like a coil, essentially, but it's like, well, it's like a cylinder essentially, which has got the chunk cut out the middle, so the water can circulate around it, and the water sort of flows through the annulus, flows back out into the return. Annulus heats up the water, but the problem with this is it scales up a lot, so it's not really used anymore. And the one on the far left hand side, this is a single feed indirect cylinder shown here. I'm going to look at that in a lot more detail in the next section, because even though it's not fitted anymore from new, we need to be aware of it because we may come across it. Alrighty, centralized and localized systems. We're going to talk about these now. Okay, so a lot of the systems we've looked at, in fact all of the systems we've looked at in part 1, and the indirect system we looked at just there at the start of part 2, all of these are centralized systems, and that means essentially that all of the water comes from one centralized point, and it goes out to several outlets. It would go out to, for example, the bathrooms, the kitchens. It goes out sort of to all of the outlets, so all of the water comes from one place. In the case of the cylinders, it's stored there. In the case of the combi boiler, it's heated there, and it goes out to lots of different places, and they'd be described as centralized systems. Okay, there are also sometimes a requirement for localized systems. We'd normally use, in all domestic properties, or certainly most domestic properties, we'd use centralized systems. We'd have one heat source which would sort of go out, or one point of hot water, which would go out to all of our appliances. But when we get to sort of larger buildings, maybe offices, colleges, sometimes there's going to be a requirement for a localized hot water system, and there's a couple of reasons for that. Essentially, if you have a long dead leg, a long length of pipe without a return on it, there's some issues that will come with that. The main issue is that the water will cool inside the pipe. If you have any length of pipe that's not got a heat source directly attached onto it, that water is going to cool down over time, and that means every time someone goes to opens the tap, they want to get hot water to wash their hands. For example, they need to run off a lot of cold water that's cooled inside the pipe before that water starts to run warm. Another issue with that, apart from the wastage of water aspect, is also there's a risk of Legionella. Because that water is cooled inside the pipe, it's going to drop below that sort of safe, out of that sort of safe zone, which is above 40 degrees ideally. Sort of it pasteurizes at 60, and it sort of goes into a zone where potentially there's a risk of Legionella bacteria growing, and if that happens, then obviously the system people are at risk from the water in the system. So yeah, sometimes it's more appropriate to fit a localized appliance. Generally speaking, you're going to have what we call single point water heaters, which will just feed one appliance. But sometimes you can get a localized water system that will feed a small number of grouped appliances, like the picture on the left hand side here. Okay, so this is a systems over here, single point water heaters here. You can see a diagram of an oversinked single point water heater on the left here, and a picture of one in the middle. And then on the right hand side we've got a picture of an undersink, or a diagram of an undersink hot water heater. Interesting fact about the undersink hot water heater, sometimes, not always, but sometimes they would be fitted with a vented tap. Sometimes you're actually allowed to use the cold water side to actually accommodate for expansion. But sometimes if they have a store of hot water in there, they might well use a vented tap. So if you actually have a dripping tap, always have a little check underneath the countertop before you start doing any maintenance, because it may actually be dripping for a reason. It may be dripping to accommodate for the expansion of hot water from an undersink water heater. So yeah, main reasons we use localized systems: it saves water, because like I say, once that water cools in the pipework, you have to run off loads of water before it starts to run warm. So we might use localized water systems to help save water and also reduce the risk from Legionella. Okay, so what we want to do is we try and keep pipes, or dead, any pipe that doesn't have a return on it is technically a dead leg. So keep dead legs as short as possible. Okay, and yeah, I mean, the big benefit of the localized systems means we get hot water straight away without any waste, whilst minimising Legionella risk. But we can help sort of minimise the risk from Legionella if we did use a centralised system by insulating the pipes. And any sort of all pipe work, all 15 and 22mm pipe work over 12 metres long on hot water systems should really be insulated. You need to make sure, well, also potentially we could install trace heating, not something normally done in domestic properties, but it's worth being aware of that it exists, because they might ask questions about it in the test as well. Okay, or potentially installing a secondary circuit, and we're going to look at that as well. That's something that is used so quite often actually, to ensure we get hot water quickly to our appliances, and this essentially stops the pipe from being a dead leg, and we'll talk about that in a few minutes. So firstly, insulating the pipework. So the best method, really, the first step you're going to take is insulate the hot water pipes. That sort of reduces heat loss, and means that you can sort of run the pipe and have less worry about the water certainly cooling as quickly. And let's say there's actually some maximum pipe lengths set out in Part L of the building regulations. Part L covers conservation of fuel and power, and that tells us pipes up to 22mm should run no further than 12 metres, hot water pipes, without insulation. Okay, so we need to try and make sure that we insulate as much of the pipework as we can. In an ideal world, we should insulate all the hot water pipe, that's the sensible kind of thing to do, really. But the building regs tell us we can run at a maximum of 12 metres without insulation. And also we need to make sure that all of the pipework into or out of the cylinder is insulated for at least 1 metre, or it says in the regs to the point at which it becomes inaccessible, because sometimes it might just go up and straight into a wall or something. Do you know what I mean? So obviously, if you've replaced that cylinder and you're insulating the pipework, you're not going to sort of rip out the whole wall to put in just an extra 500mm of insulation or whatever. You're going to just insulate it for at least 1 metre, or to the point it becomes inaccessible. Trace heating. Okay, not something that's fitted very often, but we're going to look at it. Essentially, what trace heating is, it's like a essentially a cable that gets wrapped around the pipe. They run electricity through it. That causes the cable to heat up, and that can sort of offset some of the heat losses that you might have through insulation. So you'd have insulation on top of that, trace heating around the pipe, and that can help keep the pipes hot and long dead legs. But it's not something you'd come across very often. And secondary circulation, this is something that's used very often, particularly in larger buildings. Yeah, it's definitely something worth being aware of. Essentially, this overcomes the issues with dead legs by making them not dead legs. Essentially, they actually circulate the water round in a circuit. They are pumped, and they would be connected. This is essentially the water. Oh, I'll start again. So the water flows out through here. This is going to be a sort of hot distribution pipe and vent at this point, and then this is a hot distribution pipe, which is going to sort of flow around here. And then once it gets to here, you've got your outlets coming off here, your outlet coming off here. Once you get to the furthest point, you'd have a connection in for a return. So that actually means we have hot water circulating around here all the time. This water is going to be probably 50, 55 degrees, possibly as much as 60 degrees, circulating around here all the time, which means that as soon as you open this tap, the only sort of bit of water that's going to have sort of coolish water in is this sort of meter, essentially, going up to the appliance, So it means you get hot water almost straight away, which is great. You need to be particularly careful with insulating this, because otherwise you're going to waste a lot of energy, because let's say there's going to be really hot water circulating through this all the time. You need to make sure that you use a non-corrosive pump, for example, a pump that's made out of bronze or stainless steel, and then you make that connection, the return connection, in near the top on the side of the cylinder. And quite often there'd also be like a sort of offset inside the cylinder, which would kind of kick up here back towards the sort of outlet for the vent and distribution pipe. So there's a video there that describes secondary circulation systems there, which you guys can watch in your own time when you've all got access to the video, access to the PowerPoint. Sorry. But yeah, now once you've done that, then you can do your tasks.